Hello, hello, hello. Did Murphy come? Oh, of course. All right. Let's see. 7:01 and 16 seconds. Should we get this started? Hi, my name is John. Thank you for coming, and thank you in advance for listening to me talk at you for just a little while. These are some thoughts that I've had and some research that the results of a little bit of research and some of the work that we've been doing here at Etsy. This week at Etsy is Hack Week, and as we speak, the entire company is trying to come up with weird and crazy things to do on the site, outside of the site, and they may or may not break things. This is okay, because otherwise we won't learn anything. Look, all you new people, come on over here. So breaking things. So this talk is about alert design, and at a really high level, the thing that I'm most interested in is putting investment, making effort to recognize that alerts and how we build them, how we react to them, how we view them as like a core part of the infrastructure, the applications that we build, it needs effort. It's not a, I need to know this fact, so then tell me this fact. Anybody who's ever gotten a flood of text messages from a friend, or too many people at once, or, well, frankly, anybody in a first world country knows the cost of having your attention context switched from place to place. So let's get started here. The first thing that I want to say is that this talk is not about dashboards. This talk is not about collecting metrics. There are plenty of other talks that are way better than that. Do I believe that we have anomaly detection problems? Sure. Detecting that something's surprising or untoward or forecasted to be worse than it is always a problem. One can argue that we will always have anomaly detection problems. This is not a solved problem. It's something that we'll continually have to get better at, because as it turns out, we're inventing new ways of being normal, so therefore we have to rediscover all of the ways things are being abnormal. So what I'm not interested in is how software can be used to detect anomalies automatically. That's not really what this talk is about. Well, to be fair, I am interested in that, but I don't doubt that you'll all have it figured out. And so instead, I want to talk about something else. I want to talk about this boundary that we sometimes forget about. When we look at things like dynamic thresholding and six sigmas of relevance across a normal distribution, and smoothing techniques, and signal processing, and all of that sort of thing, that's all well and good. But what happens after that? What happens after a computer has told the most adaptive and intelligent anomaly response being in the world, humans, what to do. So the boundary between humans and machines, that's the thing that I'm interested in. And that's the place where it turns out we have a lot of pain. And I'm going to say this a couple more times in here, but I believe that what I'll call alert fatigue, and say numbness as a result of alert fatigue, is a blight on our field. It's been a blight in many other industries, and I believe it's a blight on our field. How many here, raise your hand, get alerts sent by computers to tell you something's wrong? Okay. How many here received an alert today? Okay. How many of you stopped exactly what you were doing and ran to respond to it because it was incredibly useful, valuable, and life or death to your business if you didn't? This guy right here. We'll ask him where he works later. Is this shirt familiar? I would say that if we have any hope of making progress in monitoring complex systems, and these things are complex, we must take this boundary into account. So there's a couple of observations here. The space, from a marketing and product perspective, there's huge numbers of monitoring as a service, alerting as a service companies right now who are getting lots of funding because it's a big deal. Who doesn't want to know when shit's gone wrong? But I've got a couple of observations with respect to tools and monitoring that we build. Well, these are assertions, really. One, we don't use a single tool to gain insight into the architectures we build. And I'll argue that we won't ever. There will almost always be separate layers because of context sensitivity and, frankly, the way that we build tools at the moment are not viewed to be really holistic in nature. Number two is teams of people are the norm, which means communication and coordination between humans around alerts and what to do with them becomes as important, if not more important, than surfacing the anomalies themselves. Generally speaking, we do a reasonably good job of finding out when stuff is broken. I think we do a terrible job of all of the alerts telling us that things are broken. And we'll talk about that in a little while. But I want us, for just an hour, to turn our attention to how alerts affect a team of people. Number three is we bring our biases, our expectations, and our trust and perceptions to the table. And no tool or automation or display or UX or slippy map navigation with the helmet and the gloves and the minority report is going to change that. And number four, understanding the breakdowns at these boundaries. What we do with information in the context that we get them and the usefulness of that information between people and machines should be a part of how we approach designing the things. So, in other words, algorithms alone will not deliver us to a safer place. John Boyd, in '65, coined his now famous OODA loop, okay? Air Force guy. He originally intended for the OODA loop to be used in the context of air combat strategies. Who's familiar with this? Anybody? Oh, man. All right. Wikipedia. It's good. He said that in order to be successful in a combat scenario, you run through this loop, you run through this process. You observe, you orient, you decide, and act. And success hinges on which side in a combat scenario is better at this, and which side can interrupt the other side's loop. Observe and orient in this scenario is the place that we're going to talk about. So, I've got some more questions here. There's going to be a lot more questions than there are statements or answers. So if you thought that I was going to give you a bunch of answers and brilliant things to say, or brilliant solutions to all your problems, then there's beer. It turns out alert or in some circles alarms is a pretty, I wouldn't say super old, but it has, as long as there's been a control room, as long as we've, well, certainly flown planes and generated power, there's been a sense of, hey, you got to take a look at this. And a lot of smart people have looked at this, and I believe that some of these things are applicable. Neville Stanton has an incredible book. It probably costs a lot of money, but I got it for free because of a professor that I have. Inside, and we're going to talk a little bit about this, are things that I think that you'll find very familiar. Before I have these questions here, I want to point out that even these researchers, the researchers who have looked at how to better develop alerting systems and anomaly detection awareness systems, also fall prey to a lot of these things. Micah Ensley is known for her work in her career as all of the topics and considerations surrounding the concept of situation awareness. Situation awareness is the thing that Ensley does. And she mentioned that at a safety expert conference a couple of years ago, she was giving a talk, situational awareness, and it was about 300 people in a hall. Not staged or anything, the fire alarm went off. 3 people left the room. Now, this is a safety seminar, and 3 people left the room when the fire alarm went off. I don't know what's in there, but I think that gets at some of these things we're familiar. Okay, more questions. For those people who raised your hand, the alerts you've gotten, how many alerts that you've raise your hand if you've received an alert in the last week that simply weren't actionable, that you could do nothing about it. All right. Keep your hand up if you got one of those today. Keep your hand up if you've got one of those in the last hour. All right. Yeah, 2 people from Etsy, and we're really trying. Here's a better question. How many of you have gotten alerts that were received in the past week as a result of known work being done by someone else, but the alerts weren't silenced during the period? Okay, it's a thing that happens. These are the types of questions. All right, so I'm going to read a couple of quotes here. First, I'm going to read the quote. These are from real people in real jobs. And then I'm going to tell you who said it. Okay, here's the first one. Quote, a program alarm could be triggered by trivial problems that could be ignored altogether. Or it could be triggered by problems that called for an immediate abort. How to decide which was which. So we wrote ourselves little rules like, if this alarm happens and it only happens once, don't worry about it. And if it happens repeatedly but other indicators are okay, don't worry about it. Okay. That's Jack Garman from the Apollo program. I have another one here. Quote, I would have liked to have thrown away the alarm panel. It wasn't giving us any useful information. Operator, 3 Mile Island Nuclear Power Plant. And then the last one, quote, when the alarm kept going off and we kept shutting it off and on and off, and then the alarm would go off again, we'd shut it off. So I just reset it to a higher threshold. So I kind of fooled it. This is a surgeon explaining how they responded to an alarm in the operating room. So this leads us to this sort of first part of this science. Signal detection theory may ring a bell for any of you who were a psychology major. It says that in any given group of measurements, you have things that you're looking for and things that are not necessarily relevant to what you're looking for. So you have some amount of signal and you have some amount of noise, and these overlap The signal-to-noise ratio is something that we feel familiar about. So what happens here when you have overlap? You turn it up, you turn up sensitivity, and you'll get false alarms. And it's not sensitive enough, and you'll get missed alarms. So somewhere in there is the tuning exercise that we all do, hopefully, over time. But as it turns out, as we turn this sensitivity, we affect our ability to be useful when we get them. The context that we're in when we receive an alert, check HTTP, get slash, doesn't return, or maybe returns and the status code isn't something that you expect. Something it's very different if you get that alert and the site is already down and you're already responding to an outage, versus you haven't seen that alert for months and everything else seems fine. A lot of people, and we're not going to be able to talk about this today because it's such a huge topic. I think we could probably do an hour just on coping with data overload. It turns out data underload is a thing as well. So what about the context that people are in when they experience a false alert? What about the context that people are in when there's a missed alert? So this is the simplistic map of the cognitive processing of an alarm signal. This is Ensley again. So when we design alerts, we have to think about the various ways that the alert can be interpreted or acted on. Just because a graph or alert was there doesn't mean we fully understood what it meant. What was it telling us? Check HTTP. What is it telling me? Is it telling me that the web server's down? What's the next question I have? Is this site down? Or is just one web server down? Or is there something wrong with the monitoring? Or is it just okay and it's transient and I need to adjust thresholds? These are all acceptable. I can ask a myriad of questions on one given alert. But generally speaking, we do tend to throw a lot of signal just to hope that something sticks. For God's sake, somebody pay attention. Maybe if we send 1,000, maybe somebody will maybe if we set people's phones on fire, then they'll pay attention. So oftentimes we'll punt on aiding the operator with context. I think there's a reason for that, and we'll talk about that in a little bit. So first I want to give you a couple more anecdotes to scare the crap out of you. The Emergency Care Research Institute, which sounds really important, recently identified in 2010, 11, 12, and most recently a month ago for 2012. Alarms is the #1 health technology hazard. These are monitors and alarms designed to, quote, never miss. These are things like blood pressure and EEGs and EKGs and blood glucose and all of the other bit. In a period of 3 years, 566 deaths were reported to be related to alarms, most of them associated with the silencing function. Blah, blah, blah. I got it. Okay, I'll take care of it. Silence, do my thing. Oop, there, I got to go to that other patient. Still silenced. And you have complaints about Nagios' set downtime feature. So this brings us to confirmation. So because false alarms are a problem, people will spend time not reacting to an alert. And this in and of itself is a fascinating problem for me. Because they'll take time, even if they do bring action to it, to confirm that it's legit. There's something called in the aviation industry called the delay in ground proximity warning system syndrome. And the study says, I think it was 2001, I don't have it here, about 73% of the time, pilots delay responding to the ground proximity warning system in order to look out the window to confirm that the alert is legit. Okay, I'll say this out loud. ground proximity warning system. They do this. Well, it's going off, but I mean, really though, are we really going to crash? Hold on a second. Just wait a second. Let me just. No, it looks fine, Frank. Just don't worry about it. Yeah. So now we're delaying because we need to confirm, which is great because we're humans and we've got adaptive capacities. Also, pilots have a self-serving interest in landing the plane. But my question is, are there ways that we can support confirmation in the alerts that we design? Turns out there's the airport in Cincinnati. There's one of the runways in Cincinnati, and it has a riverbank right before the grade gets really steep, and then it plateaus at the landing strip. And pilots who are used to flying into Cincinnati on that runway are used to, when they get in there, because the grade is basically the distance between the ground and the plane decreases in such a short period, it sets off the alarm. So those pilots who do this almost always ignore the alarm. So now turns out that there's something context sensitive there. Also, they're ignoring alarms. So let's take a look at this normal Nagios alert. Just chock full of beautiful, clear, understandable information. I can't tell, I don't know whether it's saying that the inodes have there's 95% free. I think it's probably because it's an alert, but it's okay, because I've had a couple of beers and it's only 3 in the morning. So now, what are ways we could confirm? Now, there's some pieces of information here, and over time we'll probably get used to this sort of thing. Here's the time. Okay, well, it did tell us, it did tell us that it used to be warning and now it's critical. Thanks. So what if we did something like this? This is my incredible omnigraphal skills. What if we did something like, well, not only do I think that the disk is alerting, this is the computer talking, not only do I think that the disk is getting full, but let me show you something. Take a look at this graph. This is how full it is, and this is what the last hour looks like. It's not that it reached 85% static threshold and it took 10 years to get there. Let's say it took, about a day. And not only that, but dev shim and tempfs doesn't, or these other partitions, it don't really matter. So I'm not even going to show you. But I am going to show you really clearly, even if you don't have your glasses on, what the story is. The next part is expectancy, and we talked a little bit about this earlier when people are doing work. And in a growing site, when you get really good, you expect to do work while things are running. And a lot of times you're well-intentioned. Aveline here, so Kevin Murphy, I think he's on call, right? Are you on call, right? Aveline's on call. All right, well, Kevin Murphy might be working on a server and say, oh, you know what, I'm working on this memcache server. You know what, I don't want Aveline to get paged. And I know that I'm working on this, so I'm gonna have to balance memcache, so you know what, I'll set downtime. Let me say, 2 hours. Okay, but that's okay. And so he's doing that, well-intentioned. Aveline's taking his afternoon nap, and we don't want to wake him up. And so an hour and 59 minutes goes by, and Murphy says, this is killing me. This was supposed to be easy, but now I'm in a rat hole of sysctl, and now I don't know what I'm doing. I totally forgot that. Now Aveline's awake. Oh, shit. Aveline, I'm so sorry. Blah, blah, blah. And Aveline's like, asshole. This was a known alarm. Now, what happened? Did Aveline's trust in the alarm that he got diminish just a little bit? And if that happens a lot, will Aveline begin to distrust it more and more? So people's expectancies also affect their interpretations. In a study in 2001, 6% of operating room alarms were found to be expected or anticipated. So what are ways that we could support expectancy? So why is there this noise problem? So on the one hand, just like we said with my excellent transition earlier, was that signal to noise ratios are hard. They're hard and they're difficult to get right, especially if we're making changes and there is expected variation in the system. So the general view, the blunt view, is to err on the side of too many alarms. But unfortunately, this ignores the detrimental effect on humans. A study in 1998 said that in new air traffic control systems, missed alerts were at 0.2%, and at false alarm rates were at 65%, which means that they really turn it up. Again, air traffic control, those are the folks who have to pay attention that planes get too close to each other. So underlying false alerts is not that the functioning of the algorithms themselves. In fact, a lot of these cases, the computer did what you told it to do. Tell me when you've satisfied this condition. But it's just that the conditions and the factors that the alarm systems cannot detect or interpret. This is the primary issue. And I would say that the challenge that we have in our alert design. So this brings us to attention, and this is the thing that I feel super fascinated by. Disk is getting cheaper. Computers are getting cheaper, which means we can store lots of things, which means when we store lots of things, we might want to measure them. And because we might want to measure them, why not alert? Because I definitely don't want to find out and be embarrassed that I didn't know something when I have these beautiful, scalable, big data anomaly detection systems. Herb Simon said that information is not a scarce resource, but attention is. We say that we have, and I believe that we do have, 250,000 graphs at Etsy. So, how many of them are helpful? Also, even if we knew which ones were helpful at any given moment, how do we look at them? Do we just say people whose last name starts with A looks at graphs 1 through 10 all the time, and so on? Alerts are about directed attention, right? And we work in a cognitively noisy world, even when there's not an outage going on, right? They're essentially attention directors. So getting to know how human attention works and its relationship to context and perception, we can hope to design better alerts. We know, or at least intuitively, what the cost is. For those of us who develop software, the cost of an interruption, a context switch, this is the reason why it's good for people to have or people crave having a quiet place, or at least very loud headphones, in order to write code. Thanks for the power. There's a cost in focusing in moving your attention from, I'm doing this thing, I hope I don't screw it up, blah, 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 blah. Okay. Oh, what? Oh, crap. All right, hold on a second. Oh, right, I have to do this thing. Hold on, move that window out of the way, do this thing. All right, what the hell was I doing? Oh, right. RM minus RF dot slash, oh, I forgot the dot. There's a cost, and the article that I was reading earlier today was to think about it this way. Think about when you get into bed. When you get into bed and you have the intention of sleeping. Okay, now imagine, okay, you're trying to go to sleep, And imagine that right before you go to sleep, somebody comes in and says, hey man, did you see that article earlier today? That was totally awesome. And now, oh, sorry, I didn't know you were sleeping. Okay, just go back to sleep. How long will it take you to get back to sleep? This leads us to interruptibility. What might be the context in which someone would receive an alert? When I'm writing an alert, I think this is going to make everybody's life better. Why? Because we're totally not going to miss this. The server's down, or registrations are down, or something is broken, so therefore I'm going to tell this person, go take a look. And it's brilliant. I am so smart, and I'm proud of myself. Insert, blah, 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 git, push, Nagios, restart. Awesome. Very cool. I'm so proud. Can we anticipate the context that people are in when they receive the alert that we've just written? Imagine if the alert was a person. Imagine if the Nagios, or whatever your alerting system, was a person, right? And they said, hey, do you get a second to take a look at this thing, right? What would you say? I've written a couple of examples of what you might say. You could say, sure, go ahead. I am fascinated. You could also say, give me 3 more minutes. I just have to finish this thing that I'm working on that deserves my attention more. You also might already say, no, I already know about that. And you also might say, how did you get into my house and get out of my bedroom? Because people are in different contexts, and the costs of interruptions is hard to rectify, especially at the point that you're writing the thing. So this is what we want, or this is what we expect what we want, and I believe that there's sometimes a gap. Alerts have 2 parts, I think. Here's the data I want you to see, and here's why I think you would find it interesting. Now, this doesn't help with interruptibility, but it does help understand why the computer thought that was the case. And it could help us feed back into our better thinking on improving the design. So the question I have is, what could we do to support number 2? So in some cases, we can view this idea of directed attention in 2 ways, right? We can view it as subtle early indications of a fault. The concept of a warning, or sorting through an avalanche of data. The writer of the alert may or may not handle or imagine the difference between those. Normally, my feeling is that we want to believe that it is this. And the reality is this happens more often than we would like. But even worse is it's a general smear of both. So it can be both. So there is a paradox here. So given that we don't want to be interruptible in all contexts, and we do want to be interruptible in other contexts, there is a paradox, and that we have a cost of shifting our attention and shifting our focus as we get an alert, as we're doing work that's either an emergency or normal everyday work. So follow me here. 1, we're always busy. That's always the case. Number 2, shifting attention does have a very real cost. I think we've already established that. So not all signals are worth paying attention to. So context sensitivity will always vary. So how can you skillfully ignore a signal that should not shift your attention without first processing it, in which case it hasn't been ignored? David Woods is a cognitive systems engineering dude, super smart. He's written a paper on directed attention, and has suggested a couple of ways, this is not a fully solved problem, to how to break this paradox, leaning on a couple of things that we have sort of out of the box as humans with our perception. He calls this pre-attentive reference. How can we sort of give you the sense that things are okay or not okay and still allow you to sort of focus? And a couple of these things, one of them is sonification. Sonification is taking data and turning it into auditory signals. I don't think we do nearly enough of this. We make graphs. Graphs don't make beautiful music, although they should. One of the examples of pre-attentive reference is is NASA's mission control. I say that because it's kind of sexy, because it's NASA and rockets and space. But air traffic control has the same thing. They have voice loops. There's a lot of verbose. There's this awesome app on the iPhone. I'm sure it's for Android, Evelyn. And it's called Live ATC, and you can listen to almost any tower on your iPhone. And when you listen to air traffic controllers, if you don't know anything about air traffic controllers, you're like, I don't know what they're talking about, but it sounds super cool because I feel like I'm watching an episode of 24. But it sounds like a lot of chatter or a cacophony, really. But to air traffic controllers, they have a way of being able to listen to many different controllers and many different pilots all at the same time and have it sit in the background. This is mostly because of their experience. And what they do is they'll be able to listen because their auditory perception has this ability to say, you know what, pay attention a little bit, and you'll soon gain confidence on being able to pick things out that are important while you're also doing your work. The canonical example of sonification is a Geiger counter. Turns out looking at the needle as you're, doing the thing, looks like a metal detector, is not really useful because, you might blink and the needle might go like this. Also, radiation. So turn up the damn volume. So pre-attentive reference, this is a thing that I think we could get better at. And we've been sort of experimenting with this at Etsy as well. So now at context sensitivity. If the background and the context in which a signal arrives plays a huge role, in which scenario? If the background in which we get an alert is one of quiet, then contrast is very high. This is weird. I just got a single alert, and it's normally very quiet. This is what most designers plan for. When I send this alert, I guess maybe there might be other alerts, but I'm going to make my alert be really good. If the background is an ongoing diagnosis, then the signal can either support or contradict existing hypothesis, in which case it's important, it would stand to reason that it's important to pay attention to it. If the background is executing a response to an already ongoing scenario, then this signal can cue that the response that you're working on is wrong or incomplete. And as we try to navigate, as thousands of pages sometimes plow into our inboxes and push notifications and disable or throttle the AT&T SMS gateways because you got too many coming in at you, which is the thing. It means that the alert will change as the context changes. You may care in one case to leave your 10th anniversary dinner with your wife to go handle one alert in one context, and then the other alert, you won't even take your phone out of your pocket. You barely take your phone out of your pocket. So I want to tell you a story. I have a Subaru Outback, and it has this. It's got this on its dashboard. So what does this tell me? It seems important because brakes are important, and there's an exclamation point in parentheses. So therefore, and it's red. So it must be really important. What does this tell me? Well, I looked in the manual, and it says that, one, could be that the brake fluid has dropped past the minimum level, but only when the ignition is switched on and the parking brake is released. Hold on to that. Number two, if I'm driving, it indicates a brake fluid leak or worn brake pads. So stop the car and pull over. Or, if illuminated together with the ABS warning light, the electronic brake force distribution system may be malfunctioning. Normal braking will function, but real wheels will be prone to locking and prevent effective control of the vehicle. So stop the vehicle, shut down the engine, then restart it. release the parking brake. If both the EBDS and ABS lights turn off, then the EBD may be malfunctioning. But if both warning lights illuminate again and remain illuminated after the engine is started, shut down again, engage the parking brake, and check the braking fluid. Or if it's flashing, then the electronic parking brake system may be malfunctioning. Again, normal braking will function, but rear wheels will be prone to locking and prevent effective control of the vehicle. I feel like the last point, it should just say, your mileage may vary. Also, it turns out that when that light is on, it means that I've just turned the ignition to the on switch, and everything is on, because it's telling me that the bulb is working. So there's a lot going on in this one alert, and that's in my car. Forget about my website. So this is the question that I want us to ask ourselves. How have I taken the operator into account? How have I taken the receiver of this alert when I write it? People use monitoring tools. Arguably, machines use monitoring tools as well. But only people can adapt and improvise with a given tool outside of its original intentions of the designer. This is known as being brittle. Alerts, arguably all pieces of automation, are brittle because they cannot adapt. They do not know that Murphy's working on Memcache server. So am I hurting? I didn't get to talk about it. Data overload or data underload? Directed attention, am I hurting? How will we know when this will actually hurt things instead of improve things? We expect and want our alerts to be helpful. This notion of a joint cognitive system is one of instead of thinking of humans as moronic, slow idiots and computers as incredible Jeopardy-winning, chess-killing, sentient beings, or a master-slave relationship happening, the robots do my bidding. What if we viewed an alerting system as a partner instead of a subordinate? What if we were to view the computer as a person? What could we learn? What does the world look like if we designed alerts to cooperate with us? If trust in alerting system is such a big deal, then what can we learn about relationships between humans that trust each other? What do we know about that? We know that humans make themselves predictable to each other, to people who they trust. They know that they provide context. I don't know what body language looks in the context of Nagios, but I'm fascinated to find out. We do see blunt versions of these notions, right? For example, time periods for alerts. We can hint to Nagios. You know what? These guys who are on call are going to be sleeping between these hours and these hours, generally speaking. So therefore, this type of alert, this can wait. Just let them know during the day when they're in the office. That's okay. Why? Because the cost of waking up is a big deal. There's a notion of dependency relationships. You've got a bunch of servers over here, and they're all relying, for the better or the worse, on one server right here. You certainly don't want a problem with this server to then cause alerts to happen for all of these. Or maybe you do, but at least have the option to have a dependency. So these things, alerts, and I would argue maybe procedures and wikis, have something in common. Very much not like relationships and trusting relationships between humans. Number one, they made sense to the author at the time. Who here has a wiki at their company? Keep your hand up if you feel as though that's the place where documents go to die. Raise your hand if there are outdated run books or architecture diagrams in your wiki right now. All right. The authors of alerts and procedures and wikis were probably very proud of themselves the day they wrote it. Number two, and also, they probably solved a problem that they had. maybe a problem of the past, possibly a problem of the future. Number two, authors of alerts are not soothsayers. They do not know the context of the future. That doesn't mean they shouldn't try. Number three, alert design is about continually tuning and gardening, just like you would procedures and a wiki in order for it to have value. This requires keeping the topic alive in the organization. So when we have an alerting system as a partner, then we could approach our alert handling more as a conversation than as a static declaration. What does that look like? Hey, Dave, I'm waking you up because you told me to wake you up. And check this out. Here's the reason why I'm sending you the alert. And here's the status of the last 3 cron jobs that ran on the box. Here's the amount of time that it was since the last production deploy. Here's a bunch of graphs. Let's see. Here are the names of the people who are on IRC and active right now while I'm sending you this alert. Here are the git commits. Blah 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 blah. Is there something that we can do to, in that scenario, support confirmation? One of the things that we had done recently here as part of a Hack Week project, actually a couple weeks ago, was downtime reminder. This scenario, a couple weeks ago, actually a couple months ago, Lori Dinesa and Marcus Barzak both, on their on-call weeks, did a decent amount of categorization. We're getting to a place where we can maybe make that a little bit simpler. They did it manually. Turns out that there was something like, in one given week, 85% of the alerts that went to the pager, the phone of the person who was on call was a result of downtime that had expired, essentially the silencing of an alert that had expired. Why? Probably because well-intentioned engineers were working on the problem to help maybe beat it. We set up a thing that's just said, you know what, if it's 10 minutes, if you're 10 minutes away from downtime, send an alert. Maybe send a growl notification. Maybe send an IRC PM to the person who set the downtime and said, psst, hey, you're probably working on this, but I just want you to know that if you don't extend this downtime, I'm gonna send a page. Oh, and here's the link to extend it. I think that this is simple. I think this is really easy, and I think this is an effort towards paying attention to attention. Anyway, that's the end of my talk. Is this helpful? Is there any other questions? Any questions at all? Yes.
Touched a little bit on context sensitivity, and I was wondering if alerts couldn't be made more effective if they were more aware of context. Like my apartment smoke detector always goes off when we're cooking anything in the kitchen.
Yeah.
And one day my roommate just threw it away. And I know it's kind of annoying, but I don't blame her. But at the same time, like, that alarm's wasn't effective when we were awakened in the kitchen because we knew, yeah, something was burning maybe, but it's especially important when, like, it's in the middle of the night or maybe when no one's around.
Yeah.
And so, obviously, like a smoke detector that was in tune with our locations or whoever's in the apartment would be extremely helpful, but it also seems that having that kind of context would really couple an alert system to a lot of other states and data, and I wonder if that's always going to be a major trade-off, or if there's a way to kind of find a great balance between those two things.
That is a good question. Does anybody have an answer? I think it is a good question, and the fire alarm one is an excellent one, and it's also a great use case for, well, let's say, designing automation as a case study. So for example, generally speaking, fire alarms are normally sort of close to the ceiling, which means that they're quite good, because they're designed this way, to detect carbon dioxide and or combustion up near the ceiling. Turns out humans are really good at detecting fire if they're awake at other heights. I think that it's a good question. It's difficult for me to believe it it doesn't seem to me that there would be a silver bullet. I think that might actually be, or if we pour lots of context, let's say it's a fire alarm built by Nest. Those guys are real smart. So we say, okay, all right, you know what? Only tell me if there's a fire. If there's a fire, well, only tell me if you've detected smoke. During these periods of time of the day, but also only if you detect that there are humans in, but don't do it if you detect humans are in the area. Maybe via motion detector. Of course, that doesn't really help if you're engaged in a really, heated argument and you're not moving, but you're standing very still. As anybody who's ever gone to the bathroom and sat in a stall and the lights are on a motion detector now, you soon find yourself in the dark. My point is that I do believe it's what the latter that you mentioned. It sounds like that this is a trade-off. I think that it's less about getting to a place of finding perfect balance and making it easy to get in and out context. That sort of thing. They are. And I'd argue that putting state, right? There are alerting tools, frameworks that essentially look like rules engines, essentially conditionals ad nauseum. But the only difficulty with that is how hard are they, or how easy are they to reason about? Oh, I got this alert. Okay, then that must mean that, oh, that doesn't support confirmation, because if condition A, then else if condition B, but only if and or condition B, C, D, but not E, blah, 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 blah. Balance, no easy answers. I don't believe. So.
Yeah, well, specifically at Etsy, you guys tried to tie some of the alarm systems, various things that might fail together in any kind of unified way, or your engineers expect alerts to come from all different areas without any knowledge of each other?
Yeah, it's a good question. I mean, so the question was whether or not, do engineers expect alerts to come from various areas? And I think the answer is yes, but only certainly because we're not satisfied, of course, to have simple components alert. Components aren't really interesting unless they're single points of failure, in which case they're incredibly interesting. But yeah, we certainly have teams that have their own. Search has their own on-call rotation, and they build their own alerts. Some of them are a little bit higher. Some of them are a little bit about application behavior. Some of them are about sort of a little bit lower, but not fully down to memory, CPU, and disk. Maybe some sort of application level or code level, language level behaviors. I think that there are a couple of places where, for example, we'll alert on the trajectory of time series data, less than, say, the value in a point of time, right? The work on Holt-Winters is helpful in that case. Dynamic thresholding is quite, I think, a good idea, but there's problems that come with that as well. That still requires tuning. And so another example of this is somewhat context specific. I wouldn't say this in we're not going to win an elegance award for this, but the rate of errors, or say the error log lines per second since the last deploy. That's an alert that we have. But even those that have temporal components have issues. So for example, we have an alert of checkouts. If the rate of checkouts, the rate of people buying things on Etsy, drops below Now, I'd love to say that we're in the hundreds of thousands per second. Etsy's not that successful. But we certainly think, well, maybe there's probably something wrong if we don't get a checkout, we don't see a checkout in 5 minutes, something along those lines. Maybe something's wrong. As it turns out, that alert did fire. And Avleen was with his family. He was on call. This is 2 years ago. And he was with his family. He's like, oh my God, this is no good. We got to go check this out. Turns out it was Christmas and no one was buying anything. So what does this cost? What does this cost to Avleen? Does he like this alert now? It just on Christmas Day. Also on Christmas Day, it both heightens his context. It's Christmas morning. Crap. Etsy must be up because Etsy's about the shopping and the buying of the gifts. And it's Christmas, but yet, wait, it's bogus and everything's fine. And now that really, really sucks because I should be hanging out with my family. Anyway, I don't believe there are any easy answers. Are there any other questions? Yeah.
At what rate are false alerts acceptable?
One more time.
At what rate are false alerts acceptable? Like, I don't think you can ever get rid of them 100%. But
Right.
Where do you draw the line of false alerts and
I think that's a good question. I think I will be frustratingly annoying and answer that with another question. Will you know when your organization or the people who receive those alerts, will you know when they will speak up that the noise is hampering their ability to make progress on responding to legit signal? My experience is that we're quite, as a community, we're quite terrible at this. I mean, we know that we've certainly had I have had conversations with people. When I first got to Etsy, we went from I used to say that actually I just said it earlier today, the outages of yesterday inform the architectures of tomorrow. I would say that the alert coverage of yesterday informs the false alert rate of tomorrow. At some point, Etsy didn't have any alerts. And then they had a couple of engineers who were incredibly good at setting up monitoring. So then they had a lot of alerts. So many alerts that the pendulum flew in the other direction. When I first got here, I said, I don't think that knowing CPU on a single web server or memory is actionable. I think maybe knowing in aggregate what web servers are looking like with respect to maybe response time or error rates and that sort of thing might be a little bit better. So I think we should just get rid of this. And the immediate response was out of my cold dead hands. And I think that at some point somebody said, yeah, but when my phone is buzzing in my pocket, I know that things are working. I don't know what to do with this information. So I think the answer is, at what point is false alerts rate? You ought to just get up and leave if I said 0.5%. I think that the danger that we have is that the costs of having missed alerts the cost of having missed alerts is so high that we will turn up the gain, but at the expense of the very, very invisible cost of having too high of a gain. I believe that sort of talking about it is going to probably get it better. But imagine if all of the most successful web companies in the world were required by some rule-making body to publish how many alerts per day their engineers received. I certainly would be embarrassed. I would be embarrassed about Etsy's, and I think that we're pretty fucking good at this. And I'd still be embarrassed. I think everybody would probably feel embarrassed too. Like, oh, this could probably be better. So yeah, I think it's organization specific, but I'm willing to bet that we could probably move the pendulum in the other direction. There are proponents of saying, screw servers. I want to know if revenue and availability change, and that's it. I also think that's also a short-sighted approach. I think that there's a schmear.
It's also very cyclical. We, not just at Etsy, but at other places I work as well, you go through periods when the rate of false alerts is going up, and at some point somebody snaps and says, this is too much.
Mm-hmm.
And then everyone just jumps on it and says, okay, deal with the false alerts and bring the rate down. And then, I was talking to Kevin Murphy about this yesterday. It's not just with those alerts. We have other sort of more passive alerts and things. The cost of keeping those low, he said, is there's not much payoff, right? Why invest so much time in keeping your false alerts rate low when you can probably tolerate it going up a little bit, and then it creeps?
It's detecting when. I think the answer lies in detecting when it's tolerable, and to which extent these are consensus-driven decisions. Dave? Hey, Eric.
So, less of a question, more of an observation. The people who are designing alerts are not always the people who get the alerts, and they have different like motivation, right? Oh, monitor everything, and this one is only wake me up for when it's really fucking broken.
Right.
So that's kind of a very common disconnect between like users and designers, if you wish, right? So I mean, like, one of the ways to deal with that is with user-centered design. Is that like you basically put the people who are designing alerts in the seat of like in the context of receiving them.
Right.
So that's sort of one observation. The other observation is, and you kind of touched on it, is like we have data about, okay, we've generated this many alerts. What we're not good at yet capturing, like, there's no button that says, oh, I just got this alert and it's crap. I'm going to rate it on a scale of 1 to 5, like, oh, this is a 0, right?
Yeah.
Like,
yeah.
Netflix style,
Yeah,
When you get this alert.
Yeah.
We recommend this alert for you,
Based on the alerts you've received in the past.
Yeah. So there's a tremendous amount of data that we're actually losing. Like we're not capturing that could actually inform, oh, you've received this alert 5 times in the last week and you've ignored it every single time. So like, maybe turn this shit off.
Or like, at the very least, an indication of why didn't you feel as though it was important at the very least, right? Yeah. That is a huge, huge point. And so classification is one of the things that we've thought about at Etsy as well. I don't think we have just started we have a weekly on-call rotation, and as part of our sort of weekly on-call report, we plow out all of the things. And at the moment, it's either there was an action taken or not action taken. But Lori, we ought to just open source this computer program. I think to capture some of this was expected, meaning it was downtime, but it expired, or downtime wasn't set at all, but so it was expected. This is not this wasn't an unexpected. This was the result of somebody doing work, or this was legit. It was legit in the sense that the view, say the view of the monitoring system actually was not clear. So like IP tables magically turned on. The web server was fine. It just so happened to block incoming connections from the monitoring server, which has happened from time to time. So like, or the view is clear and it is legit. I think there's a couple of other categories. I think this is, please someone write an iOS app to do this. One of the things that we've been throwing around is having push notifications. And I think that GitHub's Allspaw has, I don't know to the extent that it has functionality, but they're certainly doing a little bit more than your plain old SMS. And so that it seems like that would be a good place to put feedback into the system. We do shove all of our Nagios, both perf data and the alert data, into Splunk, and we got certainly top services and top alerts, and we do some of that. But I think that it's like shooting a fish in the barrel. We could write some really terrible code, and it would be very useful. I think the bar is very low here. So, any other questions?
I'd go a step further with what he said. So I'd even go a step further. It seems like it would be asking for a learning algorithm to figure out what the predictors are of a good or a bad alert. So for example, the bad alert that your colleague got on Christmas, maybe the system would be smart enough to know that this was a holiday and that there's a high correlation between false positives and holidays, or time of day, or day of week, or CPU load at a given time. So you're more likely to get false alerts. There's a correlation between false alerts and high CPU load or low CPU load, or things sort of like that. In other words, to discover the correlations, it sounds like the first pass of what we do is to take our intuitions and figure out what are the correlations between good and bad alerts, but machines are good at that. So with a little bit of feedback, as the other person was saying, this is a good alert, this is not a good alert, it sounds like a spam filtering algorithm would work pretty well.
I see what you're saying, but I disagree. To an extent, I think that there is legit, I mean, like I said, the bar is very low, so the answer, I think the answer should be yes to all of these ideas. But in the case that you said, would we still, let's say Nagios did know, if Christmas, then what? Would we send the alerts to Aveline? In which case?
You would send the alerts with a certain level of confidence, perhaps, and then Aveline could decide that there's a threshold.
But what I'm saying is the cost of interruption has already happened.
Right, but it wouldn't be repeated. But it wouldn't happen again. That would be the goal. So yes, the first time you're right.
Yeah, it's possible. I mean, again, I think it's possible. Also, it turns out the only thing that makes me nervous about fully algorithmic and getting relatively too clever is the missing context. Is the context that that the software isn't going to have. I think we can probably inject a lot of context in there. We certainly inject periodicity, right? Or we can say, oh, at night, high and low watermarks are blah, and during the day, high and low watermarks are blah. But only if there's not a Super Bowl promotion. How do we encode a Super Bowl promotion or Good Morning America, Etsy's on Good Morning America? And will we, I think that all of these, like I said, I think all of these are legit. I think that we could probably get a lot of mileage in assisting confirmation and assisting expectancy. I'll tell you right now, I think that is Ari still here? Oh yeah, there he is. Ari is our MySQL DBA, and we have schema change Thursday. We do schema changes on Thursdays, and Ari is largely the one who does them, and we do a decent. We have a tool that sort of assists. There's both. It's actually quite a good tool. It's pretty cooperative in terms of putting the automated bits into place that are helpful and we have confidence in, but also allows Ari to be essentially a supervisor of the automation. And so there's a lovely mix there. And I believe that it automatically sets downtime for things like replication slave lag. Doesn't it do that? Right. And so in some cases, when they go beyond the downtime extender, I think he's been a pretty happy beneficiary of the downtime reminders. Am I wrong? Yeah. So I mean, I think that, like, again, I think that there's a lot of I think there's a lot to be gone before we get super you know, AI singularity. Any other questions? This guy right here, because he's closer to the microphone, and then Kevin Murphy.
On the human factor side, and building on the idea where you rate your alerts, I think there's also just some satisfaction at being able to talk back to the thing.
Yes.
Like, I know that already, now shut up. You know,
Yes.
so
Yeah.
that kind of thing is also just gratifying.
Right. Right.
And so it deals with your trust question. Like, sure, it was the wrong alert, but I got a chance to put it in its place.
Yeah. Yeah. I think that there's something there. I think that there really is. I think that there is something there. And if we did view these things as as cooperative agents, I think that there is. I think there is something there. It also just strikes me the other day, somebody pointed out that iPads have sort of acceleration or some sort of sensitivity on their touch, so that if you did have an iOS app, you can say, "No, really, I mean, shut up." Murphy?
Just to kind of touch on a couple things, specifically, like Lori's comment early on, where he was saying that, like, the fact that he was getting spurious pages told him that Nagios was up and that it was working. One of the things I'm working on right now is working on, like, egress level aggregation of notifications so that you don't end up with notification storms when a lot of things go wrong. But there's a little bit of a problem there in that there's sort of an anti-pattern right now where people view just the sheer volume of alerts as a proxy for the overall health of the system.
Right.
And so if you go in there and you start aggregating things and making it so that no matter how bad things are, you're never going to get more than 1 page a minute.
Yeah.
Then you just have to start asking yourself, well, in that case, how do people judge the importance of this event? Because it makes the exact same amount of noise if one web server is down or the whole site is down.
Right. Yeah, and that's a really good point. There's a something there's a bunch of references here, and in the slides, I'll link to them. But there's a bunch of papers. One of them is by a researcher, Morey and Rothenberg, and it was in the 80s. And it was about, actually, I can remember it. It's fault management in process control, and they looked at eye movement. And this, I believe, was, I don't know if it was in aviation or manufacturing. It's a reasonably well-cited paper for some surprising pieces. They said that essentially, no matter what the display, the auditory, no matter what the design of the alarm was that they're all indications, including interviews and eye tracking, is that humans process alarms serially, single-threaded. To what extent group or aggregation comes into that? I keep getting alerts, so the problem must be really bad, despite the fact that I haven't even looked at the alerts yet. Also turns out that if you rebuild Chef's search index and you have a very tight coupling between Nagios and Chef, it turns out you can send the alert for false alerts for every node that you have. And so I can see the motivation behind your solution here. But yeah, I think it is a good point. They also touch on, David Woods. This paper does talk about aggregation and grouping, and the point that Woods makes is that when you do group or aggregate, in the case of or stagger, but if you don't pay attention to including information about how to reason about again, this is sort of like assisting confirmation. If if you stick the alerts in a queue and you're trickling them out, or you're grouping them and saying, you know what, I know that within this period of time, these 30 nodes have done this, so I'll just send one big alert that says, by the way, that these 30 nodes just did this. Then taken to an extreme, then you may actually have more questions when you get the alerts themselves about when did this happen, and is this more important? Wait, is this more important than the other alerts that I had been working on? I think it was surprising to me that they had said or asserted that that humans are single-threaded on response. But I think it's a valid point. I think that a lot of the, and in this paper, Woods quotes Tufte in saying that clutter as a design pattern. Now, of course, Tufte has the perspective of UI and UX, but if you view a display or a graph as simply the delivery of a signal, in a lot of our cases, a time series graph, then I think that there is something to be studied there about reducing clutter or increasing salience, right? So we have this project that every developer who deploys at Etsy, we use this tool called SuperGrep. And once I explain it to you, if you've never seen it before, you'll be like, duh, that's super smart. Actually, our CEO wrote it when he was CTO. Basically, it's in order to increase the salience of things that you are surprised about. Like a lot of places, we aggregate our error logs and access logs and lots of logs via syslog, and we've got this big old server. And then what we do is, it's a little bit more fancy these days, but the initial version was tail minus f log pipe grep minus v, all the shit I already know about. So when the screen is blank, things are cool. When the screen is not blank, go take a look at what's there. In a lot of cases, developers will have deploynators open here, and an IRC down here, and they're deploying, and then they'll have SuperGrep running over here. Brad Greenlee recently, for Hack Week, just added, of course that's a lot of screen real estate, or what David Woods would call a decent expense of, it's not economical in terms of the visual field, but whatever, people will have a terminal window. And peripheral vision, you could probably say, is a pre-attentive reference. So you're not sort of pay attention, unless you see a bunch of scrolling, in which case you turn over here. Brad Greenlee just added sound. So at the very least, you can minimize the window, put your headphones on, and I think it's like pots and pans going down the stairs or something. What's that? And it is open source. It's called SuperGrep. But I think that there's something here. I think that I got really, I think I digressed from what you originally said. But I'm very excited about this topic, that's why. Anybody else? Any other questions? That dude over there. But you do need a mic because there are people on the internet who want to hear your question.
So I was thinking more like in the sense of context and personal preference. Is there value in getting like a standard view that everyone shares, or personalizing messages? To your 30 node point, do I want to receive the alert of 30 nodes or 10 nodes or something like that, or a post later? Like, is there merit in the sharedness or separate?
That's a good question. That's a good question. At Etsy, there's not. There's not customization of the alerts content. The delivery, however, is. It doesn't say, "Dear Kevin Murphy."
In the aggregate, different people are getting a different stream of alerts.
Yes, different people are getting a different stream of alerts. Do you mean in terms of different on-call rotations?
Yeah.
Yeah.
Different people are in different groups. Certain groups are not getting certain classes of alerts.
Right.
If we were doing aggregations, they would be getting different reports, as it were.
Ah, see. So yes, so that's, if that makes sense.
It does, but then do you subscribe to the alert in the essence of, so I work in performance capacity, am I now automatically on these alerts, or does the system possibly know I care about performance, this is a new tool, I haven't signed up for it, but we're hitting for whatever reason limits in performance. Now all of a sudden I care about it, start feeding me alerts. Or now we lose database connections, I don't care. Like kind of.
Well, it depends. Do you have input on the design of the alert, to Dave's original point? Like thresholds, criterion?
Yes.
Ah, well then maybe that would be interesting to you. I would say that there might be value. There's a couple of things here. So one, I had mentioned earlier, there's Marcus Barzak, who's in production operations at Etsy, is an incredibly deep sleeper. That dude cannot wake up. He's gotten the Bluetooth wristband, that the wristband vibrates when his phone vibrates, which is very cool. He also just like cranks up, I don't know, maybe even like puts speakers on his, which is also really weird because I don't know what his wife thinks about that. Whereas Lori Dines also, do you have two phones as well? Evelyn, Lori, a couple of other folks have two phones. That's something I know I could never do. And what they do is they'll leave their phone on, but then throw it in the drawer when they're not on call. And so it affords them some flexibility. But as far as, it's a good question. It's a good question. Yeah. Yeah, Kevin makes the point of abusing mailing list subscriptions in order to do this. And now, if for folks who use PagerDuty, we know that so they have an API and exceptions on rotations. Tell me about these, these alerts, but not these hours of this day, or definitely not this weekend because my in-laws are in town, or my in-laws are in town, so definitely send me alerts. Those sorts of things. I think what we're getting at, a lot of these things that we're talking about come down to, do I have the ability, how easy is it for me to adjust based on the context that I know about, knowing the context that the alerting system doesn't have. And maybe my notification preferences and maybe the content preferences are interesting to me, and maybe me only. So to the extent at which we can tune these things, I think it's important. I would say we could probably use a little bit more knobs and levers, but only in these particular cases. Any other questions? I don't know if there's more beer, but I bet you there is. And there is in the fridge. All right. Thanks, everybody. Thanks for coming.